All right, picking up where we left off, part C is the limit as x approaches 4 for x squared minus 16 over x minus 4. Interesting. Okay. Hey, you know what? We are going to use L'Hopital's rule here, but didn't we do this sort of limit way back at the beginning of the course? X squared minus 16 over x minus 4. Don't we know how to do that already without this new rule? Sure, we do. Right? We could factor and cancel and then plug in the 4 and get an answer. Yes, you're right. But it turns out we can also apply L'Hopital's rule because is this indeterminate? Let's think. If I plug in 4, I get 16 minus 16 is 0. If I plug in 4 to the denominator, 4 minus 4, also 0. That's an indeterminate form. So I'm going to go ahead and apply the rule. And you can obviously see my first step there. But okay, starting from the top, the limit as x approaches 4, x squared minus 16 over x minus 4 equals, with the L apostrophe H included, we repeat the same limit. That doesn't change. Still the limit as x approaches 4. But now we have derivatives. Derivative of the top, 2x. Derivative of the bottom is 1. What is our answer here? Well, 2x over 1 is simply 2x, and we can plug in the 4. We have an answer of 8 using L'Hopital's rule. Hey, what would the answer have been had we done it in the style that we did when we first started limits at the beginning of the course? Would we get the same answer? I hope so. Again, sorry for the shadows. Oh, man. I think you can still see what I'm doing here. So if we had factored the top, x minus 4, x plus 4, then we can cancel the x minus 4s, and the limit as x approaches 4 for x, the remaining x plus 4, well, we would get 8 that way as well. I don't know if, one way is faster than the other. I mean, actually probably this original way was faster. But hey, L'Hopital's rule still works because it was still indeterminate. Interesting, interesting. Now let's think, about like who wins the tug of war. Who they were both trying to approach 0. Who got there faster? Now this is really interesting. Who gets to 0 faster? Because the answer is 8. Like what? What? So it turns out there was kind of this balance that struck, right? If the numerator got to 0 faster, then the answer would be 0. If the denominator got to 0 faster, the answer would actually be infinity, right? If you divide by very small numbers, the result gets bigger and bigger. But it turns out neither one of those happened. We didn't end up with 0 or infinity as our answer. We ended up with a finite number, something in between. So there was a tug of war, but there ended up being like this balance, and this like equilibrium was met, which is kind of fascinating. Okay. Interesting problem. Okay, let's go on to the next one. D. All right, this is one from the beginning of the lecture. I know you've been anticipating this. The limit as x approaches 0 from the right. 2x over the natural log of 1 plus 10x. Okay. First thing we need to do, don't forget, verify that this is an indeterminate form. Obviously, we did it at the beginning of the lecture, but let's do it again. If we tried to plug in 0, well, we'd get 0 on the top. On the bottom, we'd have the natural log of 1. But remember, that is 0 as well, and so yes, 0 over 0. Okay, good to go. Here we are. Let's take some derivatives. So from the top, the limit as x approaches 0 from the right, 2x over the natural log of 1 plus 10x. Performing L'Hopital's rule, L apostrophe H equal sign. It's still the limit as x approaches 0 from the right. But now derivatives. Well, derivative there is 2. The denominator has a chain rule. So let's take our time. The natural log of something is always 1 over that. So 1 over 1 plus 10x. But then there's a chain rule. Times the derivative of the 1 plus 10x is 10. So 1 over 1 plus 10x times 10. All right. Let's clean that up a little bit, and we're right in the middle of that shadow. Okay. Limit as x approaches 0 from the right. It's still the 2, and then maybe we say the denominator is 10 over 1 plus 10x. We still have some simplifying to do here, right? Algebra. Huge part of the course. Here's what we can say. Think of this 2 on top as 2 over 1. And then we can flip the denominator and multiply. Okay, like so. So we've got the limit there, x approaches 0 from the right. 2 over 1 times, and now we do the flip, 1 plus 10x over 10. Okay. And we notice that we can cancel, or reduce, if you will, the 2 and the 10 to a 1 and a 5. And, okay. Limit as x approaches 0 from the right, 1 plus 10x over 5. And now that we have simplified, let's try to plug the 0 in and see if we get an answer. And yes, if we do plug in that x equals 0, what do we get? 1/5. Again, that is so interesting. 1/5. Okay, great. We got the answer. Hopefully it makes sense, the procedure. But what's up with that 1/5? So there was this tug of war, right? Which one goes to 0 faster? But again, there ended up being this balance. So we didn't get a 0 answer, nor did we get an infinity. We got something in the middle. So they kind of like, you know, I think we can say really what's happening, like the ratio of the way they approach